Welcome everybody to the NVIDIA Omniverse Insiders live stream, OpenUSD Insiders live stream, I should say. We have a very exciting episode for today. Lots of guests waiting in the wings, amazing guests, both from NVIDIA and especially from Microsoft. We're very excited. The title of this episode, and we're going to dive into content for, is called OpenUSD Digital Twins for Industrial Operations. So with us, we have, like I said, NVIDIA and Microsoft Azure experts. We're going to learn how applications developed on NVIDIA Omniverse and OpenUSD integrate with Azure IoT Operations, Fabric, and Power BI to transform industrial operations. Super exciting. This is all about the race to digitalization and digital twin. Before we get started, I'm going to just go through a couple of quick announcements, starting with, of course, CES, as you can see on the screen. I hope you can join us there January 6th to 10th in Las Vegas, Nevada. You can register today. There will also be content supported virtually. If you are going, we set up a special channel on the NVIDIA Omniverse Discord server specifically for CES. So you can tell us if you're going there and join us with some of the activities that are happening on site. It's going to be amazing. We have a link for the registration in the chat, thanks to our producer, Amelia. How generative AI fuels personalized brand accurate visuals with OpenUSD. We've talked a lot about this in the past. We had a great live stream with WPP. Check out this blog for more information, but this is revolutionizing the way that content is created and should be very helpful for all of those you working in that area. We also have released NVIDIA Omniverse Blueprint for 3D conditioning for precise visual generative AI. Obviously, generative AI is something we're talking about nearly every day. So this blog will be super helpful for all those looking for additional resources and getting started in there. We also have a bunch of live streams also on this topic you can check out on the NVIDIA Omniverse YouTube channel. Another blueprint, real-time computer-aided engineering digital twins. Digital twins, obviously, we're going to be diving into today. Very interesting use case that I think will be very impactful for many of the viewers. And we're going to dive in to show people exactly how it's done. But check out this blog. This will celebrate some of the work we're showing off today. And we're also, if you remember, people in the community for a little while, we did this last year as well. It was super helpful. Thanks to you, we were able to improve our documentation, and we're doing it again. So we want to see how well our documentation, our tutorials, our informational web pages are helpful to you and your journey with OpenUSD and development and Omniverse. We hope you take 5 minutes to answer these questions in this survey. It is, I can't tell you enough about how impactful it is to the documentation team and to the work, not only that we're helpful to you, but hopefully people all over the world. So you'll be helping other people by taking your 5 minutes to give us your feedback on what we could improve and tell us what you like. It's super, super valuable information for us here. We also have free OpenUSD training courses through the DLI, Deep Learning Institute. We'll put the link in the chat. This is free learning journey. So lots of OpenUSD focused fundamental information that is separated by modules. I think there are different steps right now. We have a 100 series, we have 200 series, and there's more to come. So it's all free, and you can access that right now at the link on your screen. Wait till after a live stream. Don't do it right now. All right, so let me see. That's it for the announcements. I have some great guests. Let me bring them up. Let me see. Here's Aaron. Hey, Aaron.
Hey, how are you?
Good. How are you doing? Tell us a little bit about your background, and then we'll bring in some of the other guests right after.
Yeah. So I'm Aaron Weisbart. I work for Microsoft. I am on I'm a principal program manager on the MCAPS team. So that's customer and partner facing. So my team, and Drew's on it as well, we spend a lot of time working with heavy asset industrial customers and kind of composing solutions for them with both Azure solutions, whether it's on the edge or in the cloud, and partner capabilities. And so we've worked very heavily with NVIDIA. I'm excited to share kind of what's brought us here today in bringing our two platforms together.
Amazing.
About me.
Amazing. We're so happy to have you here. Thank you for coming. And here's my colleague, Martin. How you doing, Martin?
Hey, how's it going?
Tell us a little bit about your background.
I'm a principal product manager. I really get into all kinds of fun projects, technologies at NVIDIA Omniverse. So lately I've been focusing on kit application streaming.
Awesome. Well, we're honored to have you here as well. And I see Aaron's colleague right here. How you doing, Drew?
Hey, good. Thank you. Thanks for having us. Yeah, I'm Drew Dudek, and I'm a technical program manager working closely with Aaron Weisbart and the NVIDIA group. I'm a nerd. Well, I've been close to the engineering effort here, kind of help drive what you're going to see today, and it's just been an excellent journey with NVIDIA and Microsoft working together. So
That's amazing. We're so glad to have you here. And then I have some other good. The All-Stars do not stop here. The Dream Team continues. Ganesh, how you doing?
I'm doing well, thank you. Good morning, good afternoon, good evening, folks. My name is Ganesh Shivraman. I'm part of the NVIDIA partnership team. I lead the Omniverse partnerships with Microsoft, and we've done some incredible work in the last few months, along with the Dream Team, as you said, Edmar, on the NVIDIA side as well as on the Microsoft side. Excited to share those with the community here.
Very excited. Yeah, everyone's in for a big treat. I've been privileged to be in the test runs for the show, so I'm really excited to show this to the world. And we're also joined by our colleague, David. Hey, David.
Hi, how's it going? I'm
Good.
David Marshall. I'm on the Solutions Architect team, and I've been helping out with most of the infrastructure and the Azure deployments and things like that. In my side job, my day job is helping onboard people into Omniverse.
Amazing, amazing. Speaking of Omniverse, we have the brilliant Sashi here. Hey, Sashi.
Hey, how's it going? I don't know about brilliant, but hi, I'm Shashi Bhushan. So I'm on the Omniverse team as well. I basically work with our partners and externals from a solutions and systems architecture perspective and help put these kinds of real world problems into our digital world.
All right, well, that's amazing. So as you can see, I wanted everyone to kind of, who's watching, get a feel for who's on the show today, so you know who to direct questions to. Feel free to do exactly that in the chat. Before we get started, we're gonna watch a really compelling video, and then we're gonna talk about this video right afterwards as a focus of this live stream. So we will be right back after we watch this very short video about something that was just shown off recently at Ignite. Very, very cool. So there was a lot of stuff happening in that video that people with fine eyes might be able to tell exactly what was happening in the background. But what you were looking at is a brilliant IoT-focused digital twin done by the Microsoft team with collaboration with NVIDIA. But let's dive into exactly what we just saw, because like I said, there are a lot of different pieces there. And as I mentioned in my promo earlier on Discord, this is all about kind of like the race to digitalization, as Ganesh said earlier in a meeting we had on the team, and about digital twins. So what exactly were we looking at? I guess I'll hand that over to Aaron and Ganesh.
Go for it, Aaron.
Ganesh, you want to kick us off?
Okay, I can do that. So thank you, Edmar. So I think as exactly you said, Aaron, do you want to put up the slide that we have? Yeah, that's perfect. So it's exactly right, Edmar, as you said. So there is a race to digitalization across all industries worldwide. And when we think about digitalization in the context of NVIDIA Omniverse, it's about building digital twin representations of different aspects of what a factory or an industrial workflow would look like. So typically, one would think about creating a design digital twin, a factory planning digital twin, even for autonomous vehicles. What we are going to talk about here in this live stream is specifically around operational digital twin, or how a factory or a manufacturing operations would work. There's also, of course, related to robotics and warehouse digital twins as well. So there's a massive adoption of industrial digitalization that's happening across the industry. And we are super excited to work with Microsoft very closely because we are bringing several different technologies that NVIDIA produces, of course, with NVIDIA Omniverse, with our AI stuff that we are doing with NVAIE and the NIMS, and of course, all the DGX stuff that we are doing on Azure. So the partnership between Microsoft and NVIDIA really helps to supercharge that industrial digitalization and the adoption of all of this incredible simulation-related workflows that we are doing. Anything, Aaron, that you would like to add?
Yeah, and I'll just comment that, like, you can tell by how fun the song we chose, how fun it is. The team's having a lot of fun together, and so we brought a lot of talent from NVIDIA and Microsoft together because we're doing this integration. We're doing it in a kind of this physical sandbox, and we're responding to customer signal in building this. So we want to provide a reference architecture and code sample out to the community as an accelerator to help others. The value prop that we're trying to target here is we work with a lot of customers who are in heavy asset industries. They might be, manufacturers, they might be energy producers. Regardless, the theme that we're seeing is they're trying to concentrate their subject matter experts in a central location to enable like this remote operations. And effectively, they're trying to keep the wheels turning. They're trying to continue to generate product. They're trying to continue to generate, bread or sales gas. And they're trying to avoid at all cost downtime. A minute of downtime in some cases could cost them $100,000. So if we can provide those remote operators with situational awareness so that in a snap, they can see and understand the context of the problem they're dealing with and get that line back up and running, or maintain it in a proactive way so they never have downtime, then we can offer a ton of value to these customers. So massive potential in digital twins. We're getting the customer signal, really excited to lay this foundation and help solve it by bringing our two platforms together.
Very cool. I mean, I think in an early meeting that Ganesh and my colleague Shashi were in, we were talking about a couple of terms I hadn't heard before. Autonomous kind of situations or environments where I think it's called lights out. Is that how you refer to it, Ganesh?
Correct. Yes, lights out. Mm-hmm.
And that basically just means there's nobody there physically. So the lights don't have to be on for people to see because all the data is being visualized outside externally to enable this support.
Yeah, exactly. There's a lot of, when we talk about industrial digitalization, kind of the real end goal is towards autonomy and autonomous systems, essentially. So the lights out condition that you're talking about, Edmar, is one of that end results that one can expect, where there's very little to no human interactions in a facility. And pretty much all of the process, manufacturing, bottling, all of that is really happening through robotics and a perfect harmony of different systems working together. That's what the lights out condition is. That's kind of the holy grail of where the industrial digitalization will take us. But there are several different systems and steps that has to go hand in hand to get there. And that's what we are here to talk about. And we're just talking about one piece of that, which is the operational digital twin piece of it.
Yeah, and one of the other challenges, obviously, the data is typically siloed, right? They're in various different formats or applications, and that's the other challenge that this solves.
That's actually a decent transition. If you don't mind, I can kind of talk through a little bit about how we build out these digital twins and some of our data sources. So a couple of data sources that we want to highlight in this one is the machine data. And so I'm going to stand up if you guys want to focus on my camera. I can talk through a little bit about the two pieces. So there's the machine data, which is coming from sensors like your temperatures, your pressures, your flow rates. And then the other piece is that the 3D context that's coming from the CAD. So the temperatures and the pressures are being controlled locally in an environment like this. And as I said, this is kind of our Houston integration hub, where we have a lot of real world industrial we have a really industrial environment with all the same tooling that you would have in the real world, but in a way we can play with it. So
we partner with Rockwell Automation. We have drives running our machines. We have their Allen Bradley PLC. It's running optics, factory talk optics. And that is talking to our local server, which acts as a gateway. We have Azure IoT Operations. So as long as we're using the correct standards, we can retrieve data off of these machines and get that picture of like what is the state of the machine.
Very cool. We might have lost him for a second there because he's walking around. That's amazing. Let me switch the slides here. I got let me see. There we go. So we lost your audio, Aaron. But what we're looking at now, let me take that off. Oh, there we go. So what we're looking at right now from an early presentation I got from Ganesh and Sashi is basically what you're seeing in the UI are actually real-time readings from the various components of the machinery we're looking at in the back that's doing different processes. And and when something goes wrong, it's highlighted in red, as you can see right there. There's an element there that's an object that's highlighted red. So there's no guessing if you're providing support on what issue you need to look at. The other thing I love about this is that this is working with Microsoft Copilot, so that you're getting natural language information back on what is the problem, or how to solve it. That is, I think, a truly amazing thing. But I don't want to understate the significance. So feel free to jump in anywhere on the Microsoft side of things. And Drew, you just got to unmute yourself. There you go.
Okay. Yeah. So you just saw Aaron in the actual facility. So that's the edge. And what you're seeing here is an actual demo of the repo we actually made open source to kind of show the developer community how to connect the NVIDIA platform with the Microsoft platform. So what you're seeing here is on the left, you see Power BI reflecting near real-time data using Azure IoT Operations, Fabric, Power BI. And on the right, you see the Omniverse Kit app streaming 3D content deployed in Azure on Azure GPUs. And you can also do some bi-directional communication between the Power BI and select, let's say, what's pump 2. And of course, my live demo is going to break, but that's fine. But essentially, you can communicate between like a product in Microsoft and the platform of NVIDIA, which is really powerful. And like I said, that's in the open source repo, and we give instructions how to deploy this. And really, what that does is it shows how to make a repeatable, scalable solution. And scalability is the key here, right? That's something we've struggled with in the past. But this is an actual scalable solution between the two platforms. And it's all sitting on OpenUSD, an open standard. And yeah, I think it's pass to Sashi here if he wants to add anything.
Yeah, thank you. So I don't know who has the architecture diagram, but
I do. I can pull that up.
So you can actually pull it up, and I can talk a little bit more deeper on it once we have a picture up. But fundamentally, as we've seen with what Aaron has shown and Drew has shown, is that we have real data coming in from sensors. And that real data then gets put into the Power Platform through Fabric and all this good stuff. Once you have that, we can then mix in analytics and we can mix in visualizations with Omniverse and Power BI into a web application. I don't know. Ganesh, you're still looking for the diagram, I'm assuming? Or are you sharing?
Can you guys see my screen?
Now we can. Great. Thank you. I really appreciate it. So I described this at a very high level, going from the edge all the way into the cloud, right? Because you can have real sensors doing this. What I'd love to do is dive in a little bit more on what that really means from an Omniverse perspective. So I'll start with where you see the bubble for number 1. And then I'll hand it over to some of my colleagues who can go in more deep. But fundamentally, we set up a Kubernetes cluster in AKS. And in that Kubernetes cluster, you can then scale to n number of concurrent users. And we have our streaming technology with Omniverse hosted there. That information is then connected in to a front-end web application. And this is what I was talking about with mixing in the data from the Power Platform using Power BI and Omniverse. Fundamentally, that web application would allow you to have cross interactions between the data, that rich data that you're getting from Power BI, and with the 3D contextual information in the 3D viewport. The USD file and the scenes are all constructed in there. It gives your users and yourselves the ability to navigate that scene quite efficiently and effectively, and give you cross selection between the scene and with the dashboard information. You would also be able to get attention getting alerts and so forth from the analytical data and pipe that back into the viewport. So the team's done an excellent job in architecting and designing this and putting this together. And I'd love for folks like David to go into a little bit deeper discussion on what it means to like stand this up in Kubernetes and putting it into an Azure tenant.
Perfect. Yeah. Thank you, Sashi. Let me go ahead and do that. I'll share my screen.
Everyone watching and joining the chat, thank you for joining. Feel free to keep posting your questions. We're putting some stars on them, and we'll hit some of them up a little bit later. And I think, David, I now see your screen. Here we go.
And so I think Drew was the one that mentioned it earlier, but we have a Git repo where you can go and go to get the README and how to set all this up. A few things I want to touch on. So like I said in the beginning, I worked on the infrastructure part of this and setting up the AKS cluster and Kubernetes and all that in the back end. So I kind of wanted to go over that. So I'm going to skip down here a little bit into the repo. And slightly hit on the prerequisites and what's required to get kind of started with this. I would say that, because I've mentioned a couple times, Kubernetes and Helm, definitely useful, as well as the being able to have certificates. So we have public DNS that we need SSL and TLS running across. We need the certificate signed, things like that. You have to be kind of comfortable with doing some of that. We walk you through step by step, but always prefer to have a little bit of comfort level with it. And then a little further down here is a diagram, which I'll pull up, that describes all the Azure resources. And I wanted to go through those real quick. First of all, like I said, you kind of need to have some understanding of setting up Azure and infrastructure. The first one here that we're using and kind of encompasses everything is our VNet inside of our resource group, which I'm kind of missing at the top here. We have a public DNS zone that we're going to go to be able to hit the API and to stream from. And then we have a private DNS zone that we have to set up internally to instead of keeping up with all the IP addresses. We have multiple subnets, each with their own use here. I mean, you can set this up any way you want, but this should be a good base level for anyone to set up this Power BI integration. The first one here is when you hit the front end of the app, when you're requesting a stream. So when we talked about front end, you're going to a web page and you're saying, I want to ask for this application to be streamed, specifically the Power BI application. We're going to click and run that Power BI application with the Kit app in the background. And that is run through the App Gateway. The App Gateway in Azure is a service that allows you to layer 7 load balance traffic. It does other things like SSL and TLS termination, and it also has a firewall in it, which is down here. That connects into this API gateway. This gateway has NSG rules, which is another type of firewall to block ports and services there. Inside of here, API, you can lock down all the API rules and endpoints and things like that to securely expose and manage, monitor all that, your APIs. And then in the actual AKS cluster, I would call this box here the AKS cluster or the Kubernetes cluster in Azure. And that is also governed by an NSG and a set of rules. We have 3 different types of node pools for the caching, general things for any agents, and then the GPU nodes, which are very specific that we need to be able to stream and run these Kit applications in Omniverse. And from there, I think if you can see and understand all of this, then we can move on to like actually deploying onto this environment that we set up that is in the Git repo and how you set that up. So the next thing I wanted to hit was NGC. So all of this comes from NGC, all the resources, all the streaming containers, the Helm charts, everything that's required after you kind of have the infrastructure, the AKS cluster set up. Inside of this, we have a couple of things that I wanted to kind of mention. And they're all listed here, but I'll have a diagram, and the diagram's in our docs at nvidia.com. This one is not on the README, but you can definitely find it in our docs for Omniverse Kit App Streaming API. It's a little bit busy, but I'm going to talk very high level about it real quick. We have the APIM that we talked about, the app gateway, and we have a couple of services in here which I want to call out. So the first one is the application service. So the application service allows for you to be able to spin up different applications, so they could have different rooms, different machines, different digital twins, for lack of a better word. And then internally, we also have a streaming session manager. The streaming session manager allows you to call on, to post an HTTP call, an API call, to request that specific version and app that you want to run, and that app will then be told to another resource that's running in Kubernetes called the Resource Management Control Plane, or RMCP. And this does like lifecycle management for the Helm charts and the resources, enables the instantiation of other charts, like these Helm releases that get set up that are all custom. And so as soon as you request this API through your post, you will get the API call, and it will say, okay, I need to spin up this whole new GPU pod, and this pod has multiple containers on it. One of the containers is an Envoy proxy, so it's just a proxy that allows you to have an endpoint and a load balancer in front of the streamed Kit app that is created. And so that Kit app is also a container that is downloaded, and that Kit app is run on the GPU, and it's just running Omniverse and stream to the browser. To get that stream to the browser, we spin up another, like I said, a load balancer in front of this Envoy proxy, and you will go directly to this streaming container to get the web RTC stream to your browser. And so as another user would come in, because you can have multiple users doing this, you could have another post, and it would spin up a whole nother GPU node for that pod, for that stream. And so those are like the high level of the pieces that kind of go together with Kubernetes here. And I would say the next part is having the outside pieces to call on Kubernetes. So the first one is the viewer. So you need a viewer application that we're going to talk about in a few minutes, and I'll hand off to do that. That viewer is what does the post request and the call and the request to say, I want this stream, this application, and so on. And then internally, we will hand it over to the Kit app that's created. And that Kit app that we created for this for Ignite here in the demo was was a Kit app that's a base streaming container that we built on and added extensions, and you can do that yourself as well. And that is run in this container that's spun up dynamically, so we can spin up for multiple users and spin them down as well, and not have to use them all the time. So like I said, the high level is to post to that API. You get your specific app, your version, and you run the Kit app streaming to your browser. Not only do you just see the app, I don't know if we talked about this, but you also can control the app. So in the browser, you can you spin around and touch in Omniverse different parts, and those parts will reflect back into Power BI. All that is done in the back end with the web app. And then I would say the other parts that really, for me, that I wanted to call out was the things that kind of gave us trouble. I think that you want to make sure that we are using WebRTC, and there are certain ports that need to be open to certain users. So that's where all these firewall rules come into play. And I think the certs for your DNS and your TLS to the users. So make sure this is all very secure and you don't have your USD files being seen by the world unless you want them to be. And from there, I would say we would want to talk about the. I think Martin has the front end next, if I'm not.
Yeah.
And I'll let you tie that into where where I left off with creating this container.
That was
That's
great,
great,
David.
David.
Thank you.
Thank you.
All right, Martin, I see your screen here. Do you want me to share it?
Yeah.
Here we go.
All right. So I'm going to talk about this piece here in the green rectangle. That's the 3D viewport. So that's your client side view of the 3D. And then David just talked about the app streaming API as a service that's starting sessions. So real high level here. This is how the stream gets initialized. You run your client that has this 3D viewport in it, and it sends a request to the stream service, who then in step 2 here starts a container, and that container has the kit application that you made. Now you can make many different kit applications, but keep it simple. If you make one, it'll spin up that container, and then the 3D viewport client side will start polling the service, asking the service about the status of the container, if it's ready to stream yet or not. And eventually it is. If you just pushed a new version of the kit application to a registry, it might take a while for it to download. But if it's a second or a third time around, it usually comes up real fast, right? So step 4 is the container is ready, it's streaming. The client gets the information about how to connect directly to it. So the 3D viewport then connects to the container, and you see the viewport in your client. So on the code side, if you look inside of the GitHub repo, there's a lot of different code there. This is a more condensed view just to talk about the connect. Starting a session. So if you look at the service component, it will invoke this create session API, and it will pass the address, the URL to the service. And then we have these app ID, version, profile arguments. And so that is the arguments to tell the service that this is exactly the thing that I want you to run, because you can deploy many different applications, many different versions on there. And then you can also pass a URL. So that would be a stage a USD stage that you would want the application to open on startup. It's optional. You don't have to load anything. But in this case, we open that factory floor. So then the polling is done by get stream session info. And then once the stream information, the URLs for connecting to the actual kit stream, once that's in, we set the Redux state in the application, which then triggers the app stream component to connect. So the app streamer is the client-sided API for bringing in that pixel stream and adding that communication capability. So out of the box, when you have this just working without adding any custom code, you get the pixel streaming and you get the viewport interactivity functionality, so that if you click or click drag, all that interactivity on the client side, it gets transmitted to the kit application in the cloud. So for this project, we added custom messaging. So we added the ability to notify the front-end client about selection changes. So you could see in the video earlier how a user selected a pump, and that selection got sent as a notification to the client, informing that reporting view about that, we want to look at the pump now. From the client, we're sending requests for what to load, for what to select. So if you're in that reporting view and you select the pump, there's a message sent to the server to please select that pump. And then we also have that asset status changed where you can highlight it in red in case the water pump is vibrating too much or something like that. And so custom messaging, when you send from the viewport to the server, it's payload based. So all you do is you really just define an event type for what to select in this case, and a payload that identifies what it is that you want selected. You use the app streamer API to send that message to the Kit application. That goes over TCP. And then on the Kit application side, you have extensions, and inside those extensions, what you do is you register the kind of events that you want to listen to. So here we have the select prim request that we have registered. We created a subscription to that event. And then we have, of course, have a handler. So whenever that event is triggered, we look at the payload and we look at some data that we know we should be analyzing, and we modify the selection. So if we want to go the other route, we want to send from the Kit application to the 3D viewport client. Here you register what it is that you want to send. So here's a stage selection changed event, and then you listen to what's going on inside of the Kit application, and when the selection changes, you can analyze what the current selection is, and you dispatch this event that you registered earlier, and the message bus will automatically pipe it through and send it out to the front-end client. And so you can look at that in more detail inside of the app stream component file on the client. The handle stream custom event has a bunch of different handlers for different events. But in this case, we're looking at the stage selection changed event. And so then, the prims that we set in this payload on the Kit side can be analyzed on the client side. Let's see. And then to wrap this up, when you want to end the stream, these are the two different code files that you want to look at. One is to terminate the video stream, and the other one is to destroy the actual session on the server. So if I start a session and Sashi starts a session, now we have two nodes running, and maybe we just allocated two nodes. So we need to end those sessions so that Ganesh or Aaron can come on later and use the same resources. So that was this piece right here. I'm going to hand it over to Drew because he integrated that viewport component inside of the larger client.
Thanks, Martin. Yeah, I got the live demo working again. So Edmar, if you want to share my screen. Oh gosh, that's really fun. I do want to point out the computer bro, TZEIT. He said, or she said, that the elephant in the room is, why is the forklift hovering? So I'm showing my live demo again. You don't have to see that mess, but this is a good thing for everybody in the session. Is the forklift hovering?
It looks good to me.
It looks good to you. Anyway, yeah, thanks, Martin. I just wanted to point that out because I think that's hilarious. We had to add the forklift. It looks really beautiful. So thank you, NVIDIA, for that. So yeah, I just want to touch on some points on at least the front end application. And really the front front end application that we developed for the open source repo is more about a sample just to show you how to integrate the two worlds of Microsoft and NVIDIA on a front end. And first off, let's just start with the Power BI. And I'm just going to go straight to the actual Power BI that this is. Most people are like, this doesn't look like a Power BI, but all we really did was create a Power BI with some transparent backgrounds and then just overlaid it in the React app. And you'll see that in the code. And let's see. So one of the things I wanted to point out was, how are we doing the mapping between the two worlds? Okay, so if I select pump 1, how does the viewport know that this is pump 1 versus this is pump 2? Which is one of the real initial baseline values of this, is in this new world of innovation, like in definitely with the younger generations coming up, like 3D contextualization is going to be at the forefront. People aren't going to want to just see a 2D dashboard. They're going to want to integrate 3D. So definitely Microsoft is starting to understand that. And we're good with 1D data, 2D data, but now we want to be able to start integrating 3D data into our platform. And that's one reason why we're working closely with NVIDIA on this. We don't want to be in the realm of like rendering. That's where Omniverse is good at. So that's why we're combining these two worlds. And what is this all sitting on top of? It's sitting on top of USD, OpenUSD. That's developed by Pixar. And we're kind of joining forces and saying, this is a really good approach. It's kind of like the HTML of 3D, right? You can use FBX, you can use OBJ, as long as you can convert your CAD, like, and import into USD. It's very extensible. So we really like that idea. And one of the ways we actually, in this demo, we were able to just quickly import a pretty sizable, like it was about 2 gigabytes, 3 gigabytes files of multiple USDs. So this is the single USD scene, the SCN Houston facility USD. And as you can see, there's materials, you can do animations, you can do textures, you can do the warehouse that's surrounding it. And this references a whole bunch of different types of files. And all I did was dragged and dropped into Microsoft Azure Storage Explorer, which basically points to Azure Blob. And eventually, we also want to integrate that with Fabric, with the new OneLake. Okay, so it's like a folder structure. NVIDIA did that very well with their Nucleus server, which you may be familiar with. But in the Microsoft world, we're going to be trying to utilize blob storage or Microsoft OneLake, which is in Fabric, to store these USD components as well as even your CAD files. So that's how we got the USD CAD into Azure, stored in Azure securely. So like, let me just pull up this control panel. So in this open source repo, we also included kind of a debug panel. You can open it up with Control M. And of course, as developers, you can figure that out by reverse engineering and finding that. But just for this live session, I'm going to show you this. You can put in your API for the OV streaming, which this is your API for OV streaming part of it in the deployment. And you get session capabilities. So you can create a session, terminate a session, and then you can build on top of this, right? So if you want session management, you can create those kind of functionalities on top of it. But essentially, you point to your service, you hit start session. So that starts the session on the Kubernetes cluster, finds a GPU that's available to start rendering your stream. And then you can point it to one of your assets that are in blob storage or let's say Fabric OneLake. Okay, so we're just giving you a sample. Again, this is the very beginning of this kind of together story of NVIDIA and Microsoft. And we're really excited about the developer community around this to just really take over. And kind of the way we're seeing it is like, if you have a blank Minecraft functionality, now you can go create your own servers. You can go create your own worlds with this. Like, this is a scalable solution that we haven't really been able to do until Microsoft and NVIDIA came together. Now, of course, Microsoft supporting USD, So again, you don't like, you can use other things as long as it's USD based, and that's kind of the fluidity here, multi-cloud, multi-rendering systems, but NVIDIA and Microsoft are definitely joining on the USD front. Let me see what I have on time here. So that's kind of what I want to show you with the USD front and the Power BI front. Now for data, we're essentially using Azure IoT Operations, like what Aaron showed, and we're streaming that data into the Azure cloud, and we're putting it into an ADX cluster, which is Azure Data Explorer, ADX, and it uses Kusto queries, so KQL, very nice to use. And so we're flowing in the raw data. Maybe we do some pre-processing on the data to find out if there's alerts, like alarm data or description, like alarms, and then we also can add like a digital twin kind of like integrator. Right now that we just decided to do something very, very small, because we don't want to build something complex. We wanted to say, here's a base, grow from it, right? Microsoft had the product Azure Digital Twins in the past. I don't know if anybody's familiar with that, but that's getting like it. We're going to release something soon that's going to be very cool with that side of things. But for this scenario, all I did was create a digital twin table, and this is how we did the mapping. To go back to my original point, so we have a module column in this digital twin, pump 2. And if I go to the live demonstration, you can see in the Power BI that we have pump 1 and pump 2 that's coming from that table. Okay, so if I select pump 2, you'll see that pump 2 gets highlighted. Well, how did we connect the two? We just did a very simple mapping in the USD. So I'm going to open up USD Composer. And so now we're in USD Composer. And you can see I selected this asset at this group level. And in the raw USD properties, we just added an asset underscore ID. And that we put in manually a pump 1 or pump 2. Okay. And if I go back to this, you can see that pump 1 equals pump 1. And using some React Redux global state, subscribing to the two worlds, we're able to connect it to the dots. And that's how we get the bidirectional communication. Okay. Again, that's base level, can be built upon. And there's going to be probably some products and our partners that can help do that at scale. But for the developing community, this is a good approach to start with, and you can grow upon it. And I think that's about all I want to talk about right now on the front end. So yes, the forklift, is it floating? That is the question.
I say no. That was fantastic, though. Okay, we've got some great questions. So let's backtrack a little bit. Some of these questions we got earlier. Thanks to our producer for starring these. First one came from actually an amazing developer in the community, Shane Reitz, from Loop Team. Let me stop sharing that. And okay, he's asking, this is great, especially the HMI overlays on the Kit app stream. What sort of latency is there between the edge and the cloud with this type of setup? So would this be a question for Drew or Aaron?
Yeah. So I'll jump in.
Ahead,
Help me out if I stumble, Drew. So the latency could be as low as 10 seconds, and it depends on your persona, right? So if we feed all this data into ADX, we could use real-time analytics to show those plots in 10 seconds, so quite near real time. If we funnel them directly into Power BI and we decide we want a refresh rate of 5 minutes or 30 minutes or what have you, then those dashboards will populate at that rate. So dependent on the need and the persona, you have some flexibility with that.
Okay, thank you for that. That's awesome. All right, next question we've got. Let me see. Can Microsoft IoT connect to different sensors, PLC, and actuators? They need to support specific data transfer protocol.
Yeah, so I think for this one, it'd be great to provide a link. So Azure IoT Operations just went GA, so they'll have a full list of the protocols. Absolutely connect to different PLCs, actuators, and sensors. Typically, you're communicating through the PLC or some other edge devices, but like the standard, the preferred standard protocol would be OPC-UA here.
Great. Okay. Yeah. Very helpful.
And then it also communicates MQTT.
Amazing. Okay, we've got a question here from, I think this was answered in the chat, but sometimes it's helpful to just talk about it also really quick for those people not following the chat. How to scan our instruments 3D objects, or any such way to do it to make a digital twin. I saw that Shane actually replied to this, noting that a CAD model is ideal, or Scott Dempsey replied to that, one of our community users. But obviously, if you have some type of 3D file, but anyone else want to add to that?
Yeah, I can add to that. So, there's various techniques that we've been exploring with a lot of our partners, where you could have both a hybrid of a designed CAD model or actual factory scanning or reality scanning, if you will, where you have LiDAR scanners that you can utilize to scan an environment. You can create point clouds out of that. And from that, using some kind of technique, whether it's automated or through manual processes, human intelligence, if you will, create meshes. Once you have those meshes and you have some photogrammetry, you can then, of course, convert that into the USD representation. And then from there, you're in your digital twin environment.
Amazing. Thank you so much for that. Okay, and here's a question regarding Isaac. Can Isaac be used with AWS? I believe it is. Okay, we have Microsoft here, just so everybody knows in the chat.
Good question. No, it's cool. Multi-cloud. We're fine.
Okay, and then we've got another question regarding
also
resources.
on Azure, definitely.
Great. Awesome. Yeah, of course. Okay, great question here from another user. How much GPU resources does a system like that require?
Yeah, I put the answer to this one in the chat, but it's 1 GPU per stream. This depends on how big your scene is for like how much RAM, GPU RAM you need. Specifically, though, we are using 1 A10 in Azure per stream.
Okay, that's fantastic.
Can I add to that one? Actually?
Yes, please.
So for the scene that we showed there, the USD, it was multiple assets that were straight CAD to meshes. So it was very heavy. Like, I think I said 2 gigabytes, but I think it was almost 5 gigabytes, right? After I thought about it. And that is able to run on a single A10. And in Azure Commercial, that runs about $350 an hour per concurrent user currently. So I saw in the chat too that somebody said like it's rent versus buy. That's totally true. But also like maybe you don't want to invest in a bunch of local infrastructure and you'd rather use the cloud so you can use your existing laptops or iPads or devices that don't have a GPU. So there's value in that. And yeah, this is actually affordable for the first time, I think, on the rent side of things.
Yeah, and if I may add to what Drew was saying, everything that we shared here and what is available in the GitHub repo as well as Azure Jumpstart is all available today for people to go out and try out. So if you already have Azure subscriptions and you already have Azure tenants, you can literally pick up all of this work, take advantage of the Azure commercial A10 GPUs, and start experimenting, build your first proof of life, proof of value, and POCs of everything that's available on Azure commercial. So that's an important point. And underlying where it's powered by the NVIDIA A10 GPU.
I think it's amazing. I think, as Drew and Ganesh just said, I think the accessibility is the thing to celebrate today. And being able to make this so available to developers across the world for their own use cases. If you joined us late, don't worry. This live stream is available right on YouTube right after we're finished. We're discussing visualization of 1, 2D, 3D data sets, digital twins, and industrial operations. Everything involving remote monitoring and autonomous lights out conditions. Pretty exciting stuff with the team from Microsoft here. Great collaboration with the NVIDIA team. Great. I'm seeing great excitement in the chat on all this stuff. I'm going scrolling back to see if we have any other great questions here. Here's one that was just starred. Let me see. I'm not sure who can take this one, but what is your take on multi-location geospatial context is required for OpenUSD and digital twin integration?
I can probably take that one. So there's probably a couple of different ways you can look at this. If you're looking at creating an application in which you might have multiple locations represented in a unified application, where let's say you had, you might have 5 different factories that you're interested in. You could have a map interface up front in which you can select which factory you want it to go into. And then once you've selected that factory, then you could have for each of those factories a USDC. And so you'd correlate that from the front end and then be able to kick off into different USD scenes for each of the specific factories. So that's one way you can look at it. Another way is, hey, what if I was like on Mars and I just want to take all of Mars and then just put that into a USDC? You could do that too, right? You could have a geospatially aware USD scene, and then you can put all of that in. You'll have to balance the pros and cons because, as David mentioned, it's going to be on the GPU resources are going to depend on the size of your scene. So if you wanted to go planetary, that might be quite challenging to put all of that into a single GPU and run that. So it becomes a systems integration and architectural decision as to how you want to put the geospatial context together.
Thank you so much, Sashi. Very helpful. All right, let me see another someone complimenting the great texturing work. So whoever the artist was who worked on that, good job. Okay, great. So reminder, we did create a Discord channel on the Omniverse Discord specifically for this live stream. So you, if you didn't watch this live, you're watching this tomorrow or next week or whenever, you can always go to that Discord channel and chat with some of the viewers there. If you have any questions for our presenters here, feel free to post there, and if I can help tag them in that and bring them into that channel later on, I will. But
so there's one thing.
Go ahead.
Yeah, sorry. Go ahead, Edmar.
I was going to say the final thing. If someone's going to ask this in a second, I'm sure. But the deck, we're going to share the deck that you've seen in that Discord channel also. So it's another great reason to jump on the Discord channel for today's stream. Go ahead, Ganesh.
Yeah, and the one more thing to add to what you were saying, Edmar, is I know that people usually ask us is how much time did it take? What kind of skills and developer personas is required? So I'll start with the timing piece, and then the rest of the team here on both on Microsoft and NVIDIA, please chime in on the developer personas and what kind of skills are typically required. So this specific milestone and the work that we released between NVIDIA and Microsoft, it was a small team. The core small team, and then of course we had some other support teams as well on both sides. We essentially got the work done in 8 to 9 weeks time frame. The entire, like the GitHub repo, the documentations, and all of that, including the infrastructure stuff that David talked about, the kit application that Martin talked about, and what Drew talked about as the front-end web applications with the Power BI and the 3D Omniverse viewport bidirectionality. So. And as we said, all of this is available on Azure Commercial, taking advantage of the A10s. So the rest of the team, do you guys want to talk about the developer persona, what kind of skill sets between 3D and the non-3D developer experience that's required?
I can start on the kit application side. You can do all kinds of things with just Python. So I'd say solid Python knowledge, and you can figure that out.
Okay, and I'll actually add to that, Martin. So I didn't know Python at all, like 6 months ago. And using GitHub Copilot, I could create my own extensions in the Kit app world. So yeah. Copilot. Gotta throw that out there. Also, you do need some front end skills if you're going to do the front end application stuff. Power BI, of course. And David, I don't know if you want to talk about the infrastructure side.
Yeah, I kind of hit on this in my section, but I would say, yeah, Kubernetes, Azure, like cloud infrastructure kind of build outs. I think also there's a lot of like public facing things that we talked about. And so having run something on a public facing website, multiple endpoints, API endpoints and website, you kind of need a little bit of background in keeping that alive and free from hackers and bad people.
I want to touch on that. So as the person that's working on creating a kit application and containerizing it, a little bit of basic Docker and then some kubectl to look at logs for applications, checking status on containers to make sure that they launch, that sort of thing. But just, I would say basic, not some deep knowledge.
And Aaron, I don't know if you want to talk about the USD side.
Yeah, I can touch on the 3D. The kind of the 3D side of it would be, you're likely going to be working with someone in a business that has already produced the CAD files, or a team that already does a reality capture and meshes it. So it's really just taking those files that are pre-existing and have already served a purpose and reusing them by converting them to USD. Not required, but fairly lightweight investment would be to do the look dev and add materials and some lighting, which goes a long way dependent on some of your advanced use cases. Yeah, but it's really just taking those mesh assets, converting them to USD, storing them in blob. Not a significant lift, to be honest.
Amazing, amazing, and really grateful to every single one of you for coming today and presenting this very well thought out and presented a package of information for everybody. Thank you to all the viewers out there. Some great comments, questions. The discussion is not just stop here. You can bring it over to the Discord server where we have that channel set up. If you have a hard time finding it, just message me on Discord, Ed Mendy. If you need to get in touch with me on LinkedIn, you can just go to edmore.net. It'll go right to my LinkedIn page, and you can get in touch with me there. You've just had a great hour emphasizing the role of OpenUSD and Azure and advancing real-time IoT monitoring. We've been sharing the resources in the chat, but we'll also put it in the YouTube description as well as on that Discord channel I just mentioned. Are there any final closing thoughts that maybe anyone wants to chime in at the last second? Maybe something we missed really quickly?
Yeah, I can probably do one last thing. Yeah, go ahead, Aaron.
Yeah, I just wanted to emphasize that this is out there. There's GitHub links. In fact, if you want to share my screen, when you do get the PowerPoint deck, there's a final slide that will have links to the different materials. So there's a nice blog post which talks about like the business value, a jumpstart guide, which is kind of where Azure collects all of its GitHub repos. And the one to highlight here is the GitHub repo, which does have sample data from the machine as well as the CAD. So actually, these gentlemen right over there, who are mechanical engineers, so they work in hardware a lot, they've CAD'd out every detail of these things, and they've open sourced it. Since they made it, they can open source it. So all the fun 3D content is available for you as you make your Hello World operations.
Including the forklift.
Including the forklift. Thank you,
Which is
Jose Rodriguez and Russell Dobre.
It's definitely not floating. Okay, cool. And I want to also mention thank you for Renan for this gentle, friendly, super polite reminder here to remind everybody that there are 2 active study groups happening on the Omniverse community Discord server, and these study groups are led by users from the community. So we have 2. We have one just revolves around OpenUSD, and that's led by Nandu Valal, who is an Omniverse ambassador for the community. They meet every Tuesday at 2 p.m. Pacific. That is fantastic. That's been happening for over a year now. And there's a nice group of people that just gets in there and talks about challenges and how to fix them. And then we have a brand new one just kicked off last week. It was so fun with Omniverse ambassador Scott Dempsey, who is actually, I saw in the chat a little earlier, who actually works on deep sea cable operations, leveraging Isaac actually in robotics, talking about the lights out conditions. But he is leading an Isaac Sim and Isaac Lab study group. And that's actually going to have their second study group today, about a half hour from now, about 25 minutes from now at 12:30 p.m. Pacific. So both those happen on the Discord server. If you have a hard time finding them, again, get in touch with me. It's going to be an exciting time for everybody. And really looking forward to what developers around the world start doing with this these great technologies and OpenUSD, bringing everything together to make wonderful things. So thank you all for joining us. Any last minute comments? Ganesh, did you have anything else you wanted to say?
No, I just wanted to thank the entire team here, both on the NVIDIA side and the Microsoft side, and really excited to see the work that has been released. Can't wait to see what the broader community of both Microsoft and NVIDIA are going to do with this. I think amazing things are going to come out of this. And then this is just getting started. There's a lot more coming in the near future as well. And we'll share those as we are making it available. So thank you so much.
Thank you, everybody. Next week, we have a great live stream with the team from Wandelbots. I posted the chat link a little earlier to Add Event if you want to add that to your calendar. But until then, feel free to engage with us on the forums and on Discord. And thank you once again, everybody on this panel, for joining us. Really, really fantastic time. It went by too quick. Next time we'll schedule a few hours. Okay. All right. Thanks, everybody.
Thank you.
Thank you. Bye bye.
Okay, thanks all.